Well, hello. We're going to start project 5 here, and I have to warn you that it's a bit different than the prior projects because the real goal in the prior projects was to kind of learn some new bit of Python. So let's learn about Python dictionaries, let's learn about Python lists, strings, that kind of stuff. In this case, we're going to learn a little bit about Python this project, but mostly what we're doing is we're applying Python to solve the kind of problems, really, that you might expect somebody who does data science to be able to do. Okay, so let's see what we're actually going to learn in here. First thing we'll learn is how to implement a random walk. Okay, this is a particular technique that's very powerful when you're trying to program something that has no obvious solution. The idea essentially is to amble through a lot of possible solutions until you find one that works. Okay, it's called a random walk, and we'll talk about that a bit more. Something a lot more low level. We're going to learn how to read a JSON file. We created a JSON file in projects 3 and 4. We're actually not going to read that file, so we can do our work. Okay. Now here's a little bit of Python that we're going to learn. We've seen classes and before. Okay. Now we're going to talk about subclasses, which is that when a class extends another class. So for example, you might add some methods or add some variables to a parent class. Okay. And we're going to see how that ends up supporting something called inheritance. Okay, where the subclass inherits a lot of his behavior for the superclass, and also overriding, where the subclass can say, hey, this method is okay for the superclass, but for me, it really should be this. Okay, so we'll see that. That's a new bit of Python. That's actually really an important part of Python. And then we're going to learn how to use unit tests, which is a testing framework that comes with Python that is a lot more powerful than what we've been doing so far to test code. It's a lot better. We basically didn't really know enough Python until now to use it because it uses inheritance and overriding. Okay, but now we're ready, and so let's switch to that and stop using doctest. Okay, now let me tell you about the project. Okay, what you should know is that there's something called a cipher, and a cipher will take a string, a message, if you will, a letter, right? Well, a message in some language. Let's just say English from now on. And then it converts it using some magic to an encrypted version, which we call a crypttext. Okay, so one kind of ciphers is a substitution cipher. Okay, and this is a generalization of a Caesar cipher, which was actually invented by Julius Caesar. Okay, and what Julius Caesar did was he says, look, let's just rotate the letters. So instead of writing an A, I'm going to write a B. Instead of writing a B, I'll write a C. Instead of a C, I'll write a D. In fact, he may have rotated by more. He may have rotated by, say, 5 letters. So instead of an A, he writes an F, and so on. Okay. So using the cipher, Fred becomes GSFE, right? So GSFE is the encrypted message, and you can tell that it's pretty hard to read. It's like, what is this? I don't know. I can't tell. But what we're going to do, the point of this project, is that you'll take a message like that, and then you'll use your knowledge of the probabilities of letters occurring in the English language. Like, for example, G followed by an S is not very common in the English language. And so you'll use that to kind of figure out that this is a secret message that happens to be Fred, right? So that's the point of this exercise, okay? Now, here's how we're going to do it. Very first step is we're going to write a class called Cipher, okay? And the Cipher class is going to be responsible for holding that Python dictionary that tells you what letter goes to what letter, okay? So A goes to F. A goes to D, whatever it is, okay, that's inside this cipher. So there's going to be an init method. And what I want the init method to do is to create the cipher at random. So it just randomly decides what A needs to go to, what B needs to go to, and so on for all the letters that we have, okay? You need to be a little careful. You can't say A goes to B, B goes to C, and C goes to B, right? Now I have 2 letters that map to B. That's not legal, okay? It should be completely separate. Okay. All right. There should be at least 2 other methods. There needs to be something called inverse. Okay. And inverse returns the opposite cipher. So instead of A goes to B, it returns B goes to A. And if you think about it, I can encode a message using a cipher, and then I can decode the encrypted message to get the original message back if I use the inverse cipher, right? So that's what the inverse cipher does. It just lets me decode messages. Okay. I also want you to have a method called encode, and to encode, what you give it is a list of strings, right? And what it returns is a list of encrypted strings, right? So it just applies a substitution cipher to each one of the strings in that in the arguments. Okay. Now, finally, there's something called similar cipher. We'll talk more in detail about that. Okay. But what it does is it returns a new cipher. Okay, a new cipher object that actually has the exact same treatment of the letters, except for two letters which are going to be swapped. So it might randomly pick X and T, and everything goes to whatever it used to go to, except T. The letter T now goes to whatever the letter X used to go to, and the letter X goes to whatever the letter T used to go to. So it just swaps two letters. Okay. Anyway, go ahead and get this class working. Do not even try to move on until you're sure that this class works. Okay. Now, once you get it working, then you'll write the main class, which is called CodeBreaker. And CodeBreaker is the code that's actually going to try to figure out a message. Okay. So it's going to have an init method, and I want it to have at least these two arguments. One of those is file name. File name should just point us to the location of a JSON file that has the frequencies of the English language. This is basically the file that's generated, and not basically, this is exactly the file that's generated by your previous two projects. Okay, so just give me that file name so that it can load it and proceed. Now, it should also have an optional argument called letters. And what that optional argument does is it says these are the only letters that we're going to be concerned about, A, B, C, for example. By default, it should be all the letters in the English alphabet and also a space and a period. The reason that I want to be able to pass it as an argument is that for testing purposes, I might say, I just want to look at A, B, C, D, E. Those are the only letters I care about. Okay. Now, there's a couple of methods that this class should have. One of those is called underscore likelihood. Underscore because it's a warning. You know, this is a tricky method. I don't want anybody else to mess with it. Okay. And underscore likelihood takes a bunch of strings, and what it returns is the likelihood that those strings are in the English language. Okay. And the way that it does that is it finds adjacent pairs of letters, finds the probability of each pair, and then multiplies all those probabilities. Okay. That's the answer. For technical reasons, it's actually better not to multiply really tiny numbers because eventually you get zero and then it's just zero forever. So instead what we do is we take the logs of those probabilities. And if the log of the probability is the likelihood, that's what we're calling likelihood. And you'll notice that you have two different pairs of letters, and I want to find their likelihood. I can actually add the likelihoods to get it, because the log of the probability, which would be a product of the individual probabilities, is actually the sum of the logs, right? So that's the reason that we like likelihood instead of raw probability. Okay. Now, the other method that you want is something called translate. This is the break the cipher method. Okay. And what it should do is it should do its best and come up with a translation of the strings in the list. Okay. And what do we mean by best? Basically, we mean that we tried a bunch of times, and this is the one that had the best likelihood, okay, of our likelihood method. This is the one that had the highest value of likelihood. We tried lots of ciphers, and this is the one we decided to keep, okay? So how are we going to do that? Well, we're going to try lots of ciphers. Let's say 10,000 at least, okay? And we'll start with just a random cipher, which is what the cipher class does, right? It just gives you back a random cipher. So we'll start with that. And then we'll see the likelihood, okay? And then we will try to swap two letters in the cipher, right? Again, that's for that method. Get me a similar cipher. That's what that does, okay? So then we try the likelihood of the similar cipher and the likelihood of the original cipher, and we decide which one of those two is better. If the new one is better than the old one, then we'll stick with the new one. I'll throw a wrinkle into this in a little bit later, but for now, let's just say that we always keep whichever one it gives me the highest probability of being correct. Just stick to that. Just keep doing that 10,000 times, right? At any given step, you have a current cipher, which is the best one you've seen so far. Then you find a similar cipher by just swapping two letters, and then you pick whichever one of those two looks best. Do that 10,000 times. I guarantee you're going to find you're going to be able to break ciphers like this.